Hey guys, so last we were in here, we were talking about rocks, and we were actually going through making rock candy in class. And so I wanted to just kind of recap from that because I don't know when we do get back to school, if we do get back to school, if we'll even be able to discuss it. So we had gone through, and for anyone who maybe now that you have more times would want to try and do this, we were making our own rock candy, and the recipe was basically just 5 cups of sugar and 2 cups of water. If you start off the water boiling first, add your sugar to it, mix it up, bring it to a boil, and then we poured it out. Here I just used mason jars. We poured it out into mason jars, and I used wooden skewers. You could use anything, wooden popsicle sticks or something like that. Sometimes people use string. The one key thing that I do suggest, I've done it a lot, and what seems to work best is if you can, the day before, get some nice sugar to harden up on top of your skewers or popsicle sticks. I just mix it up in a water solution and coat it in it, let it dry out. That really seems to help as far as like seeding. It works as like a seed where more sugar and stuff will collect and get added to it. So then you just let it cool, right? So this has been cooling since last Wednesday. Today's Monday. And these were kind of serving as representing the inside of the earth, right? Where we have a lot of molten magma. And we said that this would be, obviously really, really hot, but it would also cool off much slower than if it was at the surface, where once magma comes out, it can either flow out of a volcano or it could explode out, right? There's different types of volcanoes. But once it comes out of the top, it's going to cool off really quickly when it's exposed to the Earth's atmosphere. So in this case, it cools off much more slowly. And as it cools off, one thing that I really wanted to point out here that we won't really get to see in class, but this is kind of second best. It's a little drippy here. I'll let those sit for a second, and I'll pull out these 3. This one ended up working out really well. But we ended up getting, because it cooled off so slowly, some really nice crystal formations there. I don't know if you guys can see those, but they're big crystals, nice and big. And that's what happens when magma can cool off really slowly, right? This is a classic rock candy that you guys come across like at the store. And then on the flip side, I'll show you this one. I just kind of took a little bit on the side and just poured it off, okay? And this is in aluminum foil, and this one would have cooled off much more quickly, right? Because it'd be, again, exposed to the Earth's atmosphere. It would cool off more quickly. Oh, again, this one was covered in tin foil too, so that kind of helped keep in the heat. But with that, we can see that we get smaller crystals. There's still crystals here, but smaller. So the faster it cools off, the smaller the crystals are in the igneous rocks, which is what we saw with obsidian. We said obsidian actually doesn't form any crystal structure at all because it cools off so quickly, right? So these would represent like inside the earth, and this in the foil would represent at the Earth's surface. Again, we called those intrusive igneous rocks, inside the earth, intrusive, and extrusive igneous rocks on the Earth's exterior. We flavored these strawberry too, and that's pretty yummy. So if you guys want to make that at home, you can go ahead and do that. It's pretty easy to do, and just give it, honestly, this was pretty well formed after about 3 days. So if you started that up today, you could have it done by the weekend.